Hi everyone, I'm Arpita. I will be presenting gated feedback recurrent neural network paper today. A recurrent neural network is able to process a sequence of arbitrary length by recursively applying a transition function to its internal hidden state for its symbol of the input sequence. Recurrent neural networks have been widely studied and used for various machine learning tasks, which involves sequence modeling, especially when the input and output have variable lengths. Conventional way to encode this hierarchy in an RNN has been to stack a multiple label of recurrent layer. Most recently, new method of gated recurrent unit was proposed, which adaptively remembers and forgets its state based on the input signal to the unit. It's very similar to what LSTM does. However, there is slightly change between GRU and LSTM. In this paper, author proposes a novel design for RNNs called a gated feedback RNN. To deal with the issue of learning multiple adaptive timescales, the proposed RNN has multiple labels of recurrent layer like stacked RNNs do. However, it uses gated feedback connection from upper recurrent layer to the lower ones. The paper also proposes to generalize the clockwise RNN by allowing the model to adaptively adjust the connectivity pattern between the hidden layers in the consecutive time steps. This helps RNN to store short time as well as long-term dependencies. GFRNN outperforms the conventional approach to build deep stack RNNs. Authors suggest that this change is because the GFRNN can adaptively assign different layers to the different timescales and layer-to-layer interaction by running to gate these interactions. GFRNN is evaluated on character label language modeling and Python program evaluation. Both charts are representative example of discrete sequence modeling, where the model is trained to minimize the negative log likelihood of training sequences. The advantage of evaluating the model with the task is that we can artificially control the difficulty of each input. Model was compared with 3 different RNN architecture, a single layer RNN, a stacked RNN, and a proposed GFRNN. In the experiment, 3 different units, 10H, GRU, and LSTM were used. The size of the model used in character level modeling were same. Gated feedback L is a GFRNN with the same number of hidden units as a stacked RNN. The number of units shown is basically number of hidden units multiplied by number of hidden units per layer. As we can see in the result, the curves of stacked GRU and stacked LSTM has outperformed the rest of the stacked RNNs. This is a test of BPC of model trained on a Hutter dataset for an 100 epoch. And we can see the stacked 10H value is 1.892, and for GRU gated feedback and gated feedback L is 1.855 and 1.83, whereas in LSTM, gated feedback is 1.842 and gated feedback L is 1.789. After observing how well GFRN performed, it was further trained with LSTM unit by fixing the global gets to 1 to validate the need for global reset gets. As we can see, the GF-LSTM without global reset gets suffers a lot as compared to the GF-LSTM with a global reset gets. Conclusion: results were consistent over different datasets and clearly demonstrate that gated feedback architecture is helpful when the models are trained on complicated sequence that involves long dependencies. Paper also showed that gated feedback architecture was faster in wall clock over time over the training and achieved better performance compared to standard stacked RNN with the same amount of capacity. Critique: significance. 4. Significant contribution. Introduces a novel technique that really helps us improve our deep stacked RNNs. Deals with the issue of learning multiple adaptive timescales. Credibility, I will give 5. It's very convincing. Use a large and different types of data set to test the model to make a performance conclusion. And a good explanation of why certain experiments were done and what was the author trying to achieve from that experiment and how will it help him to reach the end goal. Writing, very good. However, I think there could be a certain improvement that could be made in the writing section. That's basically adding architecture for RNN and gated feedback RNN. And also there is, I have to jump a lot back and forth to understand the architecture and how the network was proposed. Discussion question: is GFRN better than LSTM? If yes, then why? And what are the downside of using LSTM for the same scenario? Does proposed architecture helps in improving the performance of an LLM with 10 units? Thank you.